This is Unit 9, Lesson 4, Adding and Subtracting Rational Expressions, Part 2. These examples are going to get a little bit more complicated because they have a lot more factoring in them. We touched on this in the last section just a little bit, but we didn't go very far into it. So what you're going to do here, if you look at this, I've got an x squared minus 3x minus 10 and an x squared plus x minus 2 on my denominators. If you have a trinomial on the denominators, the first thing you're going to do is factor those trinomials to see if they have any factors in common. If they do, it's going to make your life a lot easier. So that's the first thing I'm going to do. I'm going to factor here. Factors of 10 that subtract to give me 3 are 5 and 2. So I've got x and 5 and x and 2. My 5 gets the minus, the x gets the plus. And on top here, I still have that x minus 5. On the bottom here, factors of 2 that subtract to give you 1, that would be 2 and 1. It would be a plus 2 and a minus 1. And on top, I would still have the x. Now, looking at what I've got here, notice this one had an x minus 5 and this one has an x minus 5. I am allowed to go ahead and cancel out those x minus 5 since they're both in common in a numerator and a denominator. Now, if the x minus 5 had been over here, I would not be allowed to do it. But since this is a single fraction, I can cancel out or simplify that fraction within itself. So I'm okay to do that. So when I do that, I'm left with a 1 on the top and an x plus 2 on the bottom, plus the x over x plus 2 times x minus 1. They both have an x plus 2 on the bottom, but this one has an extra factor. This one has an x minus 1, but this one doesn't. Okay, they both have the x plus 2. I need this one to have both of them that are the same. So since this one has also the x minus 1, I need to put the x minus 1 over here. And remember, if you do anything on the bottom, you also have to do that to the top. So I'm going to multiply the top and bottom by x minus 1 so that I don't change the value of the fraction, I just make it look different. So on the top, I have x minus 1. On the bottom, I have x plus 2 times x minus 1. Here, on the top, I still have the x, and on the bottom, I still have the x plus 2 times the x minus 1. Then I'm going to add like terms on the top. So x plus x is 2x. So I have a 2x minus 1 over x plus 2 times x minus 1. That's all I can do. That would be my final answer. For the next one, I'm going to do the same thing. I'm going to factor. Factors of 6 that add to give you 5. That would be 2 and 3. So I have an x minus 2 and a minus 3. Here, x squared minus 9. That's x plus 3, x minus 3. I still have a 5 up here, and I still have the 2x minus 3 here. The next thing I'm going to do is ensure that they both have common denominators. So we need to look at what they have and what they need. Both of these have an x minus 3. So I don't need to multiply either of them by the x minus 3. But over here, this one has an x minus 2. This one does not. So the right-hand fraction needs an x minus 2. If I put it on the bottom, I also have to put it on the top. The left-hand fraction has the x minus 2 and the x minus 3, but it does not have the x plus 3. So I need the x plus 3 here. If I put it on the bottom, I also have to put it on the top. Now at this point, I need to FOIL the top here. So that would be 2x squared plus 6x minus 3x minus 9. That's all over these three factors. You are not, at this point, going to have to multiply those together. Just leave that denominator as it is. It'll make your life a lot easier. Okay, let me kind of separate these a little bit. That is minus the denominator. Again, I'm going to leave the same. and I'm going to distribute here. That's a 5x minus 10. Then at this point, I need to subtract this from, or I need to subtract 2x squared plus 6x minus 3x minus 9 minus 5x minus 10. Okay, now that minus distributes among both of those terms. So that's a minus 5x and a plus 10 when I'm adding my like terms. My denominator for my answer is going to be the same. I'm going to say x minus 2 times x plus 3 times x minus 3. I do not have to do anything else there. And then I'm just going to add like terms. So 2x squared doesn't have any like terms. That just comes down. 6x minus 3x is 3x minus 5x is negative 2x. And negative 9 minus negative 10, that's a plus 10, that's a plus 1. Then I could look at this and say, are there factors of 2 times 1 is 2? Are there factors of 2 that add to give me 2? There are not, so I can't do that. That's as far as I can go. That would be my final answer. For this one, the denominator here is x plus 3, here is x plus 4. I've seen students do this before. I want to point this out to make sure you understand this will not work. I've had students say, okay, this is x plus 4, so I need to make this an x plus 4, so I'm going to add 1 to the 3. So they add a 1 here, and they add a 1 here, which mathematically makes no sense at all. It doesn't make sense. So they say then that's an x plus 4, forcing them to be the same. And here I have 3x plus 1 plus 2x plus 1. Totally wrong. Don't do that. When we're finding common denominators, we have to multiply factors together to get the denominator. You cannot add anything to the top and bottom and expect it to work out mathematically. It just doesn't. So that's totally wrong. Don't try to do that. What I'm going to do is I'm going to say, okay, this has a factor of x plus 3. This one has a factor of x plus 4. So to make them the same, if this has an x plus 3, this one needs an x plus 3. So I'm going to put an x plus 3 on the top and on the bottom. This one has an x plus 4. This one needs an x plus 4. So I'm going to multiply by x plus 4 on the top and on the bottom. Then I'm going to do the math. I will distribute here. That's a 3x squared plus 12x over, I leave this the same, x plus 3 times x plus 4. Plus, I FOIL this one. That's 2x squared plus x plus 6x plus 3 over, I leave the bottom the same. And I'm going to go ahead and make them the same order so that it looks nicer. So those are the same. Okay, I just flip those around. I'm allowed to do that, commutative property. Then I'm going to add like terms on the top. So 3x squared plus 2x squared is 5x squared. 12x plus x is 13x plus 6x is 19x plus 3. That's all over x plus 3 and times x plus 4. Then I should double check and make sure it doesn't factor, make sure nothing cancels. 5 times 3 is 15. Are there factors of 15 that add to give you 19? We've got 1 and 15. They add to give you 16. We've got 3 and 5. They add to give you 8. So that doesn't work. That's all we can do for that one. Looking at this one, we have 3 terms instead of 2. The way we're going to do that is the same. It's nothing different. These are both understood to be over 1. So they both need the same denominator that this one has. If this one has an x plus 1, these both need an x plus 1. So if I multiply the denominator by x plus 1 here, I need to multiply the numerator by x plus 1. If I multiply the denominator by x plus 1 here, I need to multiply the numerator by x plus 1. And then I'm going to do the math. 2x times x plus 1 is 2x squared plus 2x. That's still over x plus 1. Here, 3 times x plus 1 is 3x plus 3. That's over x plus 1 minus 1 over x plus 1. My x plus 1 is my denominator. Now I'm going to add the like terms here. So 2x squared doesn't have any like terms, so that's just a 2x squared. 2x plus 3x is 5x. And 3 minus 1 is a 2. Then I should double check and make sure it doesn't factor. 2 times 2 is 4. Are there factors of 4 that add to give you 5? 4 and 1. So I have a 4 and a 1 here. So I have a 2x and an x. 2 times 2 gives me 4. 1 times 1 gives me 1. That's over x plus 1. And they are both pluses. So that did factor, but the factors aren't in common with anything down here. So there's nothing I can do here. That's as simple as it gets. Here's one that's similar to the ones we've been doing. Go ahead and pause the video, see if you can get that done on your own. Okay, here's the answer. The first thing I did was factor the x squared minus 25 into x plus 5 and x minus 5. Then I saw that this one had an x minus 5. They both have the x minus 5, but this one needed the x plus 5. So I multiplied the top and the bottom by x plus 5. Then I distributed the 2x to the x plus 5 to get 2x squared plus 10x. Then I added my like terms. You may have your numerator in a different order, but that's okay. As long as you have the same sign in front of each number, you should be fine. Nothing cancels there because nothing else factors. There will be occasions where you have fractions within fractions with these type problems. And when you have something like this, you're just going to do one problem at a time, a little bit at a time, and work your way toward the end. When I have something like this, what I want to do is get a common denominator for the numerators, the common denominator for the denominator, and then combine everything that I get. So for this one, this has a 16, this has a 4. I know that if I multiply 4 times 4, I will get 16. So this one has 4 times 4, this one needs another 4. So I'm going to multiply the top and bottom by 4 to get my common denominator. Here, I've got a denominator of 16 here, but I need 1 to have a denominator of 16. So if I have a 1, isn't that the same thing as a number over itself? So couldn't I write that as 16 over 16? That's the same thing as 1, and now it has a common denominator. So if I combine these terms, I've got x minus 4 on top over the 16 divided by x squared minus 16 over the 16. Now it's like one of the problems that we had in the second lesson. We can rewrite that as x minus 4 over 16 times 16 over this factored. That's difference of squares, so that would be x plus 4 times x minus 4. And my x minus 4's cancel. My 16's cancel, leaving me with 1 over x plus 4 for my final answer. For this one, it's very similar to that, but we have more variables here. This denominator has an x, this one needs an x. This one has a y, this one needs a y. So I'm going to multiply the first one by y on the top and bottom, the second one by x on the top and bottom. That's a subtraction. When I subtract those from each other, the denominator is xy, and I have y minus x on top. For this one, again, a 1 needs a denominator of x. So I can rewrite the 1 as x over x. Anything over itself is 1. And then if I combine those fractions, I get on top x plus 1 over x. Then I would rewrite it. The top fraction, y minus x, over xy, times this one inverted. That would be x over x minus 1. Here, the x's will cancel, leaving me with y minus x on top over y times x minus 1 on bottom. And that's all I can do. That would be my final answer. Here's another one that has some fractions within fractions. Go ahead and pause the video, see if you can get it yourself, and then we'll come back and look at it. So for this one, I needed a common denominator here. I needed an x squared, so I multiply the top and the bottom by x squared. When I combine those two, I get 1 minus 2x squared over x squared. Here I needed an x on the top and the bottom, and over here I needed a 2 on the top and the bottom. So that left me with x squared plus 4x plus 2 on top, and the 2x on the bottom. Then I invert and multiplied. I left the top fraction the same, times this fraction flipped upside down. I noticed that the x's cancel, and then I just multiplied straight across. So that's 2 times 1 minus 2x squared and x times x squared plus 4x plus 2 for my final answer.